20 minutes at the end for Q&A. Please use the chat feature at the bottom of your screen to ask questions so we can unmute you. Please use the chat feature at the bottom of your screen so you can ask questions, and we will answer questions in the order that they are received. Please keep your cameras on if you don't mind, and when we get to the Q&A section, we will please be ready to unmute yourselves. I'd like to introduce our speakers. Joining us from Bala Consulting Engineering, we have Elizabeth Larsen and Ciarán Smyth. Elizabeth Larsen is a sustainability engineer at Bala Consulting Engineers. Elizabeth is Bala's sustainable engineer and leads our Sustainable Futures initiative, a team of engineers who educate and research sustainability strategies and initiatives to help reduce the built environment's impact on climate change. Elizabeth oversees Bala's carbon accounting and mitigation and climate risk and resilience strategies, such as whole building life cycle assessment, building electrification, and other approaches. She is passionate about designing projects that prioritize well-being, reduce our impacts on the planet, and better serve our community. Elizabeth completed her master's in sustainable engineering from Villanova University. She has a civil and environmental engineering degree from South Dakota School of Mines and Technology and studied abroad at Novia University of Applied Sciences in Vasa, Finland. Ciarán Smyth is a senior project manager at Bala. Ciarán is a leader in the design, management, and implementations of sustainable MEP systems. As a mechanical engineer with over 21 years of experience in the UK, Middle East, and the US, he brings a wealth of knowledge and perspective to projects. His engineering designs consider the impact of MEP systems on the built environment as well as the planet. Ciarán is passionate about sustainability and enjoys working on high-performance buildings. He is committed to helping our projects use renewable resources and systems that ultimately reduce their carbon impact on the planet. His projects include facilities for the transportation, commercial, hospitality, and education markets. With that, I'd like to pass it to Elizabeth and Ciarán.
Thank you so much, Laurie, for having us, and good afternoon to everyone today. We're really excited to be talking to you about the topic of BERDO and discussing some of the potential opportunities, but also challenges. So as Laurie said, we'd love to take questions. Please put those in the chat, and really we want to make this as interactive as possible. So with that, we will get started. Today, we really plan to hit on three major topics. One, getting into what is BERDO, why did it come about, and why is it so important? Then we'll talk more about how do you comply with BERDO, but we wanted to take it a step further and look at how you can optimize your solutions and savings rather than having just a reactive compliance focus to more of a proactive optimization focus. And then finally, we'll address some of the potential challenges we see with compliance with BERDO 2.0 and address some of the major solutions that are out there. So what is BERDO? BERDO, it was first enacted in 2014 by the city of Boston, and that is now referred to as BERDO 1.0. BERDO 2.0 was recently updated and enacted in 2021 and is focused on building emissions reduction and disclosure. And it sets requirements for large buildings to reduce their greenhouse gas emissions within the city of Boston. The goal with this ordinance is to reduce emissions to a net zero status by 2050. But we wanted to quickly take a step back and look at where does this come from? Why is there a focus on emissions in the built environment? As you take a look at the graph on the left, you can see that buildings make up a major portion of the global CO2 emissions that are emitted annually. Building operations alone make up 28% of global CO2 emissions, with building materials and construction making up another 11%. That is a large portion, and one of the major reasons why we're looking at the building industry first in a effort to reduce the impacts of climate change. On top of that, as our cities continue to look at how to decarbonize and they baseline where their emissions are coming from, they're finding that buildings make up 70 to 75% of the CO2 emissions of their respective cities, meaning that buildings are a first priority for a lot of cities in the region and across the globe. So Boston has specifically set goals for their community and community-wide action. Their goal is to have a 50% reduction in CO2 emissions by 2030 and a 100% reduction or a carbon neutral status by 2050. This also includes municipal emissions, adaptation to climate change, mobility. But as we talked about with 70% of Boston's emissions coming from buildings, it's a major first target. Now we have to identify how can we actually start to achieve these very lofty goals. And it goes without saying that these goals will not be achievable without many industries and many partners working in tandem. The building industry is one piece of a larger puzzle that is required in regulating and getting to these carbon goals. We have to recognize that utilities play a large role in this. As Laurie mentioned, as we continue to electrify, we need to make sure that our grid is keeping up and greening or decarbonizing with us. This also requires action from occupants and users of our spaces, in addition to individuals within the transportation market, industry, and many more to accomplish these goals. So now that we've sort of addressed the larger picture, we wanted to get into the more nitty-gritty details of what BERDO 1.0 and what BERDO 2.0 are. So BERDO 1.0, as I said, enacted in 2014, laid out a requirement for 4 groups of buildings to report and disclose energy and water use. These buildings were over 35,000 square feet and residential units with 35 or more. Owners of these buildings report using the Energy Star Portfolio Manager tool, which is an online tool where you can upload energy and water use data, which the city can then take, understand, and disclose. And you can find all the data for buildings of this type online. What they did in enacting BERDO 2.0 was taking the work that they've already done in 1.0 and adding upon it. So in BERDO 2.0, they have added 2 new groups of buildings, buildings of a smaller size, all the way down to 20,000 square feet for non-residential projects or buildings, and residential buildings of 20,000 square feet or greater, or 15 units or more. So there is a new group of buildings that is going to be required to take part in this energy and water reporting. And the second primary change that came from the BERDO 2.0 enactment is the switch from a solely energy reduction focus to an emissions reduction focus. Currently, buildings are required to report on their energy and water use. But in a minute, we'll look at a timeline with emissions limits coming into play in the near future. So what are you required to do right now as it relates to BERDO and BERDO 2.0? Owners are of buildings that are over 20,000 square feet are listed on the city's covered buildings list. If you are on, or if your building is on that list, you will be required to report to BERDO. You can go into your BERDO reporting account, which is housed on the City of Boston's website, and you go in and claim your account and attach your buildings to your specific account. Then you go through the process of collecting energy and water use data for a single calendar year. In addition to gathering data on basic building information, like when was the building built, what square footage is it, and if you can, get square footage by use type. That allows you to have more granular, detailed information. So through this process, you upload or partner with Eversource and National Grid to upload electricity, natural gas, steam, and other utility data to Energy Star Portfolio Manager. You then connect your Energy Star Portfolio Manager account with the City of Boston, and that is your form of reporting it to the city. The second step, or the third step, I suppose, is logging into the specific BERDO reporting form, which is part of your claiming your account. There will be a form attached to that, and you fill in additional information such as, do you have renewable power on site? Do you offer EV charging? What sort of backup generators are you using? Were they in use more than just testing in the calendar year? And this provides the city with more information and potentially an explanation if there was high energy use, low energy use, or anything like that. It helps you and the city understand where some of that load profile is coming from. And then finally, for the 2022 reporting year, it was required to have a third-party verification. So to do this, you are required to engage with a third-party verifier. It can be a PE, it can be a registered architect. There's a list that is proposed by the city for what those certification or accreditations are, and you need to engage with that third-party verifier to make sure that your energy and water use data and your BERDO reporting form are filled out properly. This process, the third-party verification, happens the first year that you report and every 5 years after that, aligning with the emissions reductions, which we'll talk about in just a minute. So this is what hopefully just happened for most of you. If you have not gone through this process for 2022, you are required to do so. And the reporting for the 2022 calendar year, which they call 2023 reporting, is going to be due May 15th of this year. So it's a continuous annual process. So definitely be looking out to do this information and get your information submitted to Energy Star Portfolio Manager and the BERDO reporting form quickly. So that's a little bit about the current process. As I mentioned, there will be emissions limits that will start to come into effect in the near future. Starting in 2025, emissions limits will be applied to the first set of 4 groups of buildings, the buildings which are over 35,000 square feet or over 35 residential units. These emissions limits will get gradually will gradually tighten until they hit a net zero status in 2050. This reporting would happen for the calendar year of 2025, and the first emissions report would then go in and be due May 15th, 2026. For buildings that are in the new group of buildings under BERDO 2.0, emissions limits start to apply in 2030, which with the first reporting year being May 15th, 2031. And as I said, it will gradually decrease until we hit net zero at 2050. Again, this is in alignment with the third-party verifications required every 5 years as the emissions limits get tighter every 5 years. This is highlighted on the table on the screen. As you can see, the emissions limits that will be set are based on building use. A reason why knowing your building use by square footage is important. You can blend these emissions limits if you have a mixed use property rather than just using one straight value. As you can see, they also decrease all the way to a net zero status in 2050, as we've been talking about. Now, the real compliance with these emissions limits come from the fact that you must be below these emissions limits, or you will have to pay an alternative compliance fine. And we will take you through a quick example of what that looks like. So just as an example, with publicly available data, we looked at the Prudential Tower, which is about 1.2 million square feet. Generally, office space utilizes electricity, gas, and district steam for its different uses. And they reported their energy data as part of BERDO 1.0 and have been doing so for many years. So their data is publicly available on the City of Boston's website, and they average around 4 kilograms of CO2 per square foot. Looking at the office limits for the 2025 through 2029 timeframe, there is an emissions limit that is set on office buildings at 5.3 kilograms per square foot, meaning that they are compliant with the emissions limit. They still need to report every year and go through that annual process, but no fines would be assessed for this first 5-year period. However, as they get more stringent and we look at the 2030 to 2034 range, the office emissions limit reduces to a 3.2 kilograms per square foot limit, meaning that if the energy use stayed the same in the Prudential Tower, they would be non-compliant for the 5 years that and on after 2030. And to calculate the fines for this, you would take your emissions that you have for 4 kilograms per square foot, subtract the emissions limit, multiply by your square footage, convert to a metric tons value, and multiply by the $234 per metric ton fine, which would be assessed, meaning that the Prudential Tower would see fines of about $225,000 per year for the time frame of 2030 to 2034. And to reiterate that again, that is a $225,000 fine per year. And then that would increase as the limits decrease if they stayed the same throughout, till 2050 and beyond. So in some instances, this can be a, low fine, and in some instances, it can definitely be significant. So looking at this in a graphical format, this is what we think is really important for existing buildings to do. To look out to 2050 to start to identify how we can comply, but also optimize our compliance with this, with these emissions limits. The stepped down green line are the emissions limits for this building, and the dotted line is the assumed energy use and emissions for the building. This is assuming a linear decarbonization of the grid, which is defined in a report that the City of Boston did in 2021, and aligns with their intended grid decarbonization goals. So we can see that the Prudential Tower, in this case, would hit their or be above their emissions limit in 2030. But if we are able to look out and look ahead, and we see that their systems are coming, to the end of their life, approximately 2023, 2034, we can start to identify what can get us to that point where we would then, maybe need a new system and can relook at the energy use of the building. Something that we can do in the interim, which is a really great way to understand your building and to reduce emissions, is by doing a retro commissioning study. Or an ECM, energy conservation measure study, to identify low or no cost options for energy reduction. And in some cases, doing a study just to understand your building better can actually take you from non-compliance in 2030 and move you out to non-compliance to 2035. And by then you might need to redo your systems. So there are different ways that if we can understand the building systems that you currently have and compare them to the emissions limits, we can try to optimize and really take advantage of different energy strategies to push out compliance as much as possible. We did want to hit on BERDO, which is Cambridge's BERDO. We know that many individuals within, Boston work in Cambridge and Boston, and Cambridge is coming up with a very similar emissions and energy disclosure ordinance. So BERDO, similar to BERDO, stands for Building Energy Use Disclosure Ordinance. It differs slightly in the fact that each building will be given an individual baseline based on their energy usage from the time of 2018 to 2019. For buildings that were built after that time, the first 2 years of their operation will be used as the individual baseline. And then buildings will be given 3 different pathways for energy reduction. They're broken out into large commercial, small commercial, and residential. And you will have to show that you have a 20% reduction for large buildings by 2026. A large drop of 40% reduction by 2030, and so on. You can see in the graph. There is an expectation that large buildings will comply first, starting with compliance requirements in 2026 to hit a net zero target by 2035. And small commercial and residential, being a lower portion of Cambridge's emissions, has a little bit longer timeline where they start to have to comply in 2030 and hit a net zero status by 2050. Something that is special to Cambridge is that condos are exempt from this BERDO ordinance, though that may be revisited in 2030 when they revisit their proposed legislation. This is currently a proposed ordinance, but it is highly likely that it will, within the next 6 months, be enacted and go into law. So that's a little bit about the details and how we can really optimize our solutions. I'm going to pass it off now to Ciarán to talk a little bit more about the design side and some of the challenges and opportunities we see.
Thanks, Elizabeth. Hi, everybody. Yeah, in terms of how do we get there, there's really A couple of things that we need to look at. Elizabeth mentioned earlier energy conservation measures, and that's typically, I mean, I think a lot of people are probably familiar with that with regards to LEED, which is already out there. That's typically looking at your operational side. But we also have to start looking at the body carbon side of things as well, and that's the materials and things that are used in your buildings. But in terms of energy, the intent that we'd always look at from an MEP standpoint is that prevention is better than cure. If you can stop the heat from getting out of your building or getting into your building, depending on what season you're on, then you have more of a chance of reducing the overall size of your HVAC systems, which goes a long way to driving down your electrical demand in your building. And although that mightn't be possible in a lot of instances, particularly when you start thinking about life science spaces, which are very energy intensive because of their processes and not necessarily because of the building that they sit within. But if we were to take a look at this from a passive standpoint, the first place we'd look at is probably the facade. If you have a well-performing facade, you're very likely to have lower HVAC costs and energy demands in your building. Again, kind of pushing the process side of the building to the side for that. You'd need to look at something like that for your life sciences buildings, but offices, resi, even municipal buildings, the first place you want to start is with the facade, and then start to take a look at your systems beyond that. Do you have fossil fuels running your systems? Boston is in a heating dominated part of the world. We tend to use a lot of heat. It's not necessarily the cooling side of things that knock this into a more difficult place to be. It's really the heating side of things, because traditionally most buildings have used either steam or gas or natural gas, and they perform very well for what they need to do. But unfortunately, given natural gas as a fossil fuel, the intent of this is to eliminate it as much as you can. And then we look to, when we start off with the facade and look at the systems, if you can reduce the loads, then you're getting into a place where you can probably electrify easier. We do have to do this in tandem with the utilities. There may be instances where the electrical feed is not there. There may not be enough power, and that's something that you'd have to look at on a case-by-case basis. Given that this is for existing buildings, there's not much you can do about location. So again, it would be looking to try and reduce any sort of load, any sort of electrical load for your building, starting off with the MEP systems. They tend to be the biggest, and then start to take a look at your own processes as well within the building. And then when you get to a place where you can electrify, the idea is then to use renewable energy to provide that power for you. And that can be in the form of purchasing RECs and things like that. There's a multitude of different options that you have there. So this is the sort of path that we see forward to enable building owners and operators to be able to get in compliance with BERDO. I don't think it's going to be easy for every building, to be honest, particularly with existing buildings. They'll require some surveys, some a look at what you have there, what can be done, and in some instances, there's only so much that you can do. And somebody, I think it was Laurie, mentioned earlier, we're in uncharted territory here, really. So there are some known unknowns, if you like. We don't know what's coming down the line, but we want to try and prepare people as best we can. So, I do talk about a new building here. New buildings will just have to be in compliance, and you have a fresh slate to start with when you've got a new building. But you don't have a fresh slate to start with when you have an existing building. And as I spoke about, first thing you probably want to look at is, do you have gas in your building? And that's probably the first system that you'll want to start to tackle. We're seeing a lot of air source heat pumps going into retrofits in buildings, which are able to do heating and cooling. There are limitations to those, particularly in the colder weather. I will say that technology is advancing. And we've been speaking with certain manufacturers where their products can go down to like -10 degrees, -15 degrees. Although I will say in certain buildings, we do have owners who still provide gas-fired boilers as a backup. And a project that I've just recently worked on, which was approved by the BPDA, they allowed that to happen because they felt that it was necessary in case some of the air source heat pumps, which we had to redesign to go in there, if they were not capable of keeping up during the very colder months. As I mentioned before, the envelope, build it right, keep it tight type thing. Trying to get as much out of your facade as you can. On existing buildings, that might be providing more insulation for some of the older sort of stick frame buildings. It might be replacing your windows. Again, all of this does run at a cost, especially in these days with the price of materials being very high. Although you might want to check that against the fines that you might incur if you don't comply. So there's a bit of a balancing point there. And like I said, power available for all electric. That's something that you'd need to review with whoever your building engineer is to determine whether you can actually get these systems to be installed. Like I said, the technology is advancing. Manufacturers are very aware of this all across the country, not just in Boston, where net zero is a drive for many people. So they're starting to react to that. It's been a little bit of a slow go, but we are starting to see manufacturers take on some of their equipment that they can get more efficient with, which will eventually help building owners and operators.
Something that is critical to do as you're looking to comply with BERDO is to, as you're determining design strategies, to look out and really do some good long range planning. Design needs to be a balance between the upfront cost and the operational expenses, which are now being added to by the potential for fines in the future. So in this case study, we were able to compare a few different design options for a building in Boston, which will have to comply with BERDO emissions limits. As you can see, the traditional and code level designs that are common are above compliance or are not in compliance, in 2030. So if this building is, going through design right now, it may not be operational until 2025. And within 5 years, this building would be out of compliance with BERDO emissions limits. Now, as we start to identify different opportunities for using, all electric systems, using renewable power, in addition to the potential for future clean steam, we can start to identify and look out when will these different systems be in or out of compliance with the emissions limits. We can also start to calculate what this would mean for cost, not only from a capital expenditure versus operational expenditure, but also from fines. So in this example, we take two of the design options, the traditional and the all-electric designs, looking again at the difference between the two systems when they would be in compliance or out of compliance with the BERDO emissions limits. Now, what we've overlaid on top of this graph is the fines that would be seen from each of these systems. With the traditional system, seeing fines, as we've mentioned, from 2030 really on through 2050 and beyond. Whereas we don't see fines until around 2040 for the all-electric system. So comparing those, and these are simply just the cost differences in fines, let alone the difference in energy expenses. But the traditional design, as we've talked about, is non-compliant in 2030. It will amass over $1 million worth of fines between now and 2050. As compared to the all-electric design, which will be in compliance until 2040, potentially a time when you would need to redo some of the systems anyways, and you can choose more innovative and efficient technology that comes out by then. But looking out to 2050, you'll see a drastically reduced amount of fines, sitting at around $260,000 worth of fines rather than over 1 million. Now, to put that into terms for what that means now, as we're looking at the capital expenses, we took those fines and put it into a net present value. So what is the value of that money now compared to me spending it in 2045, 2050, etc. And the difference between the two designs is over $370,000. And this is just fines, again, not including the energy savings that you would see from a more efficient all-electric system. So this is to mean that if a all-electric design is less than $370,000 more than the traditional design, you would be saving money simply on fines alone by going with an all-electric system. So we bring this up to really highlight that long-range planning and looking at both the CapEx costs versus OpEx costs, and now adding this additional component of fines is really critical when we're making design decisions up front for both new construction and existing buildings. Again, looking from a reactive compliance focus to really a optimization and proactive approach to your buildings. With that, we want to open it up to questions. I know we went through a lot of information and we wanted to provide time to have a really in-depth discussion. So thank you all. We look forward to your questions.
All right, so there were not any questions entered in the chat, so we can just ask folks to fire away with their questions.
I can start. What challenges what have your clients struggled with when they're trying to figure out how they're gonna adjust to all these new regulations?
I'll take it. I think the first thing that they've struggled with, I mean, Elizabeth and I have been part of when people have come to us to do their BERDO reporting, is that what's going on? That's the first question that they want to know, is like, how do I get myself into compliance is the first thing, pulling all of their utility data together and then understanding what they need to do. And I'm going to use the word, like, it's a scary place, because some of these fines, they can be quite lofty, but the reality is that we don't know how these fines are going to be sent out. We don't know where the money's going. It's still a little bit unknown for something like that. But I think the intent is to bring buildings within Boston up to a standard for which they can serve the community and serve the people better. Now, there's always going to be some sort of balance, and there may very well be in the future when people try to become compliant and they just can't meet the emissions, that they can go back to the authority and say, well, I've done my best here, I'm still not doing it, so what happens? And the answer to that question is we don't know, and it's a very valid question from building owners and operators, but in the very first instance, they are absolutely going to have to understand where their existing capital projects are now in comparison to where they need to be for BERDO. So I think the first thing that we're seeing is that there's a lot of unknown out there, and people have been reaching out to various engineering companies to help them through that. So that's the first thing I think we've been seeing. Would you agree, Elizabeth?
Yeah, I would echo that there is a lack of data that is available. Well, I wouldn't say available, a lack of data that has been reported and is unknown to many building owners. going through this process, a lot of building owners were looking at their energy use from a kilowatt hour perspective for the first time, understanding the different, use that they had throughout various months, different peak demands, rather than just simply looking at the bill or the cost. And we had, many owners saying, I haven't looked at my bills in a while. My facility manager takes a look at that instead. And so I think there's been a lot of just the data collection has been difficult. And I would say that the city of Boston, I think, was smart in starting early with people just tracking energy and water use so that we have some time to figure out where we are, to baseline, so that when the emissions limits do go into effect, we will have at least had some years to look at this long-range plan, get it into our budgets before emissions limits start.
Great. We have a couple more questions in the chat. Sharon Stanley asked, have building materials caught up with, or will they be available to make these conversions or new builds that meet them? I just know residential systems seem to need backup systems that don't comply.
In terms of building materials, yes, there's been a lot of work done for furniture, for even for structure, for walls and things like that, and we call them environmental product data sheets, that have information with regards to their carbon emissions. So on the sort of structural engineering and architectural side, I think there has been a lot of advancement. There's a long way to go yet. On the MEP side, not so much. We don't have manufacturers who are producing those EPDs for their systems. For example, a fan or a pump. There are so many components in a fan and or a pump that to put an EPD together for all of that is proven quite challenging. Those are being looked at by manufacturers, though. There are commitments for the structural engineering group and on the MEP side to meet net zero goals by certain, I think it's 2040 for the structural engineering group and 2035 for MEP.
2040 for MEP, yep.
2040 for MEP. So manufacturers and designers are aware of this and are trying to get information. Ourselves at Bala, along with many of our colleagues in the industry, we're writing to manufacturers asking for this information. But I do appreciate that not all of it is there. We're trying to work through things as best as we can. And I will say this, I don't think it's incorrect to challenge some of this BERDO reporting either. Like I said before, if you have a building that is not going to get compliant, I mean, what do you do? I don't know the answer to that yet. I think if you show intent to get your building up to standard, I think that's a very good start. But the reality is it's just unknown what's going to happen if buildings don't comply. Those fines kick in. Who issues the fines? Where do they go? It's just a little bit unknown right now.
To clarify, there are individual compliance pathways which are available, and various exception pathways that are available on a case-by-case basis. None of this has been implemented yet, as the city is still trying to define and establish a review board for this process. But that is something that is available on a case-by-case basis. And as Ciarán said, if there is intent shown, sometimes that can, we assume, as we're going through this process and as the review board is established, that will be able to be reviewed by that review board.
Thank you. Next question, Mark Watkins asked, how does this compare to other markets and what they're doing?
A lot of other markets are formulating, if not have already formulated, ordinances similarly. Some great examples on the East Coast include New York City's local law 97. This is a very similar law focused in putting emissions limits on buildings within New York City that are over 25,000 square feet. And they similarly have a ramp down every 5 years, hitting a net zero status by 2050. Local Law 97 and BERDO go into effect within a year or two of each other, 2025-ish. So New York City and Boston are certainly aligned with this. We're seeing other cities and states do this as well. The state of Maryland as a whole recently passed what they're calling the Climate Solutions Now Act, which will, as part of this act, develop a regulation and ordinance for the entire state of Maryland, which will be very similar, focused on energy and emissions reduction. As we spoke about, Cambridge is doing very similarly. DC has a very similar program called a Building Energy Performance Program, or a BEPS program, focused again in 5-year increments to have energy reduction for various building types and various building sizes. So we're seeing this definitely increase. Each one has some of their own variations. You know, will offsets be allowed? Will renewable energy that is outside the grid region be allowed? Those are some of the differentiations that we see between each of these laws. But we do see this really proliferating across many different municipalities.
Thank you. One more question we have is from Steve White. Will U.S. companies be able to compete globally given the burden of the cost of compliance with these goals?
Oh, I don't even know where to start with that one. I don't know. I will say, you know, they are very stringent goals, and the price of construction, and not just on materials, but the price of labor is very high at the moment. So I do see this being a challenge for some buildings. How that is translated to how the US compares globally, I don't know. But I don't think that the city's intent is to make people, you know, go out of business. But it is going to be a challenge for certain buildings. I think some buildings will be easier to get into compliance, and some buildings won't. But it is going to incur some costs. But ultimately, if everybody does reach this goal and we do use renewable energy, then the intent is that, you know, you have a better place, that with better performing buildings that are not emitting carbon, and so that then translates to a better community, cleaner air, you know, a better sense of community, which hopefully will enhance the spaces that people work in and the places that they work for. Sorry, I don't know whether that answers your question or not.
Yeah, another thing I would say, going back to the notion that we are one piece of this broader puzzle, is that, you know, as we start to see money from the Inflation Reduction Act and others in many cities, we start to see that money and those incentives and rebates come about. I believe that this will hopefully be easier for some entities to take advantage of that. But that is an area where we may need some government assistance. Certainly organizations in the New York City region, like the energy, the DEP, excuse me, and the DOE, the federal DOE, they're all coming out with different incentive programs, different research programs to help, one, with the actual implementation and costs of implementation, as well as research for reducing the costs of, you know, geothermal heat pumps in general, making sure that heat pumps work in cold regions, and making sure that they're not just a specialty item, that they are, and consequently reducing those costs. So it definitely is needs to be a concerted effort from our industry, but also from the government, also from manufacturers, etc.
I have a question with the with hospitals and research facilities, life sciences. I know when they heat their heating systems, they have to use 100% makeup. They don't recirculate their air. So will the electric steam boilers be able to compete with natural gas boilers in this region when we face polar vortexes? Because I know from my husband works in this area in facilities, and the natural gas boilers really struggle when we have these polar vortex weather conditions.
It's a great question. And I did mention earlier that there are instances where you'll have backup systems which are natural gas, because the all electric systems on like the heat pumps, they do tend to struggle. I would say even 2 years ago, manufacturers were only committing that they'd be operational down to maybe 5 degrees F. Now there are manufacturers out there saying that these air source heat pumps, which would provide the hot water for the heating systems, like you mentioned, Laurie, the 100% makeup air, which there's a big demand during the winter, that they are capable of going down to -20. We did review Vicinity, our steam utility here in the city, and they do have a system of network of steam distribution in the city. When we tried to use it for a particular project, it was rejected by the BPDA because they had mentioned that whilst Vicinity were claiming it to be green steam, they didn't provide enough information from what I could gather. But it is an option. I think the intent is, like, for one of that same building that we done, we were allowed to use, we had to reduce our fossil fuel uses by 95%, which meant that the 5% when we're using the condensing gas fired boilers, that was just for those really intense cold periods. So it's from the projects we're working on here, when we go all electric, and we've done a couple of all electric buildings here, each one of them has a gas fired boiler in it to be able to deal with those, like you said, the polar vortexes. And again, that's cost. It's also space in your building that you need. So all of these things are starting to, layer upon layer upon layer. Once you have a system in there, why would you need a second one? That's it's a valid argument. But right now, the idea is that you got to go all electric, try and use those more efficient heat pumps. And if you do need backup in your building, then it is a good idea to put in gas-fired boilers, particularly for things like life sciences and hospitals, which they incur backup systems all the time, just in case something happens. So in instances like that, it's probably not as intense, but for commercial buildings, you probably don't need as much of the 100% outdoor air, like you're only providing it for the occupants of the building, and not necessarily the processes which happen inside of it. I hope that answers your question.
Okay, we don't seem to have any more questions in the chat at this time.
Well, thank you very much, everyone. We've really enjoyed this. Laurie, I don't know if there's anything you need to wrap up, but thank you, everyone.
Yeah, thank you.
Thank you. I believe usually they send out a survey regarding the workshop. If you have time, that would be great if you could answer the survey. But if there are any other questions, thank you so much, Elizabeth and Ciarán, for spending time with us and answering our questions. That was very informative. I thought that was fantastic. The presentation put things into perspective. I learned a lot, but thank you so much for your time.
Thank you. Take care. Have a great weekend, everybody.
Yeah, thank you.
Bye-bye.